In this part of the course, we are going to look at the implementations for the validator and the evaluator. So of course the validator will first check to see if an expression is valid. If it isn't, then we don't even want to try calculating it, or evaluating it rather. And then the evaluator will do the work of actually solving the expression. So a couple of things about this. The code to write both a validator and the evaluator is very tedious to write, and at this point in the course, I'm pretty sure you've written enough of that kind of thing that having you spend like 30 minutes writing this out wouldn't be that useful to you. So how we're going to do this is we will write the test classes for both the evaluator and the calculator. We won't do test-driven development after that, though. We'll write the test classes first so I can give you an idea of how I made sure that each thing functioned properly. And then we'll just actually copy and paste the code into Android Studio, and then I'll take you through some of the important parts. Like I said before, a lot of it isn't that new or useful to you, but there are a couple things that I want to talk about. In particular, for the evaluator, I use something known as regx or regx or regular expression. And this is basically a way that we can, in Java and Kotlin and other languages, examine strings and kind of perform logic on them based on what we see. So that's the one thing I do want to kind of emphasize, because knowing how to use regular expression, syntax, and stuff like that is useful. But other than that, we're going to try and get through this pretty quickly, because like I said before, there's not a whole lot new here. Okay, so let's go ahead and create our test class. So again, in the test package, new Kotlin file or class, and we're going to type validator impl test class blah blah blah. You get the idea. So what we're going to do is we will create a validator. Now this thing, because it doesn't need to hold reference to any other objects or anything like that, we're actually going to make it an object instead of a class. So what that'll look like is we'll say validator equals validator impl. So we want to know whether different mathematical expressions are valid or not. So how we would go about doing that is we would write out a whole bunch of valid and a whole bunch of invalid expressions. We actually only need a few valid ones. We're more concerned about invalid expressions. And we want to make sure that whatever we give this thing, it's deciding whether it's something that we can solve or not. It's pretty self-explanatory. We're going to have two test functions, but in those test functions, we're going to have a whole bunch of different assertion statements. One test function will contain the valid expressions, the other test function will contain the invalid expressions. So let's start by creating the various expressions. So we're going to say valid expression. Oh, great typing skills here. 1, which will be a string, but we can actually skip that part. Okay, so we'll go valid expression 1 equals 2 plus 2. Let's hit Control D twice, so we'll have 3 valid expressions, 2, 3, and they will be of varying degrees of complexity. So we'll do 6 times 8 divided by 6, how about? And then for the other one we'll do 6 plus 8 divided by 2 minus 7, and that will suffice for that. Okay, so next we'll work on the invalid expressions. So invalid expression 1 equals, I accidentally hit insert 2 plus. Let's hit Control D about 4 times. 1, 2, 4, there we go. 2, 3, 4, and 5. So next one we'll have concurrent operators, so 2 plus plus, that doesn't really make any sense. We'll do an expression which just starts with an operator. If it starts with an operator, that's probably not going to work. Then we'll worry about some decimals here. So I don't want to see concurrent decimals, and I also don't want to see something like 0.0.0 plus 1. That doesn't really make too much sense either. So I'm sure there's a lot of other things we could add in here, and it really just depends on how badly our users really want to break the calculator. So the next thing we'll do is we'll write out our test class here. So we'll say test fun test valid expressions equals run blocking. And then we can set up our test cases. So what we'll do is we'll say val result 1 equals validator dot validate. Oh, so what we're going to have to do, we're going to have to actually create this validator. So let's go ahead and do that before we can actually write these tests easy. So we're going to go to the data package, go to new Kotlin file, and we'll call this one validator impl. And of course, as I said before, this is going to be an object, not a class. There's no need for it to be a class. And this thing will extend our interface. That's one of the handy things about objects, is they can still extend our interfaces. And that's perfect. That should do. Okay, let's just use the proper function call here, validate expression instead of evaluate. So what we'll do is we'll start with our first valid expression. Valid expression 1, there we go. And of course what we'll do is we'll just assert false result 1. And what we'll do is we will assert true, that true was returned for result 1. Go ahead and import that. And there we go. And so what we need to do next is, of course, we just need to repeat this for all the other kinds of expressions. 2, 3, 2, 3. All right, and that's all we need to do for that. Let's just go ahead and fill out the other test case. Obviously, this is not proper test-driven development here. This is just kind of doing it. We're backing our code with tests, but this is kind of a different approach because I wanted to save time. Okay, so in this particular case, now we need to work with our invalid expressions. So let's just add that in, and in. And here we're going to use assert false instead of assert true. Okay, and we'll just set up the other two cases. So here we have invalid expression 4 and 5. And we have result 4, result 5, copy paste. And there we have it. So those are all of our test cases. So what we'll do next is, like I said before, we're just going to copy and paste the actual implementation here, and then we'll just kind of go through it really quickly. So in the resources section, you should find the appropriate code. Go ahead and copy and paste whatever you see there into your validator object, and we can proceed from there. All right, so like I said before, there's not too much interesting going on here. Basically what I've done is I've just broken up all of the different test cases, more or less, into different helper functions, which all return booleans. And so if the helper function returns true, for example, is the start of the expression invalid? If it's true, then we ultimately return false from the validator. So anyways, there's not really anything too special going on here. We just have different ways of manipulating the string. So has too many decimals per operand. This one was probably the most complicated to write. In this particular case, I split the expression up into basically a list of strings based on using operators as delimiters. So we're dividing based on these characters here. And then we basically looped through the list of strings and counted how many decimals existed. So in this particular case, that was to solve expressions which contained something like 0.0.0 kind of thing. So anyways, the rest of them are really quite tedious to write, but nothing too complicated going on. Just checking to see, do we have like plus plus? And notice how I'm making extensive usage of helper functions here. So in this particular case, because we have a lot of logic to write, it just really helps to make the classes much more legible and easy to write by just breaking them up into lots of helper functions. So that's it for this class. Let's have a look at the evaluator test class. So again, I'm going to right click and go to new Kotlin file, and this one's going to be called evaluator impl test. So what I'll actually do is I'm going to copy the valid expressions and paste them in here. And then we will copy in the answers, or not copy in, but we'll write out the answers to these expressions. So valid answer 1 will be 4. Then I'll just hit Control D, 2, 3, and so this is going to be 8. Oh, one thing I forgot to mention. So the characters which we return will automatically have .o added onto them. So I made this mistake earlier. If you just, for example, type 4 for 2 plus 2, that's not actually the result we want, because we're going to be basically calculating using doubles or floats. I think doubles, but one of the two. So anyways, just bear that in mind. And then of course we have 3.0. So all we're trying to do here is we just want a couple different expressions which have varying degrees of complexity and have some bed mass kind of thing going on. So we want to make sure that 8 divided by 2 is being evaluated before 6 plus 8, for example. So that should be sufficient, and then we'll just write out a single test case here just to test all of the different expressions. So we're going to type @test fun test valid expressions, and obviously we won't be writing a test for invalid expressions because the validator is supposed to pick up on situations where the expression is invalid, but if there is some kind of error, we'll still be able to have our result wrapper capture that. So this is going to be almost exactly the same thing as before with the validator, so I'm just going to copy and paste this. And what we'll do is we'll say evaluator. Of course, we'll need to actually create our evaluator now, so we'll say eval equals evaluator impl. Again, this will be an object, so we'll go ahead and create that in the data package. New file or class, and this will be called evaluator impl. It'll be an object extending evaluator, implement members. Cool, and there we go. Yes, import that. And this will be evaluate expression. And so it's a suspending function, so naturally we'll need to add our launch coroutine builder, run blocking coroutine builder. And then we can finish off the rest of these statements. So this thing is not going to be returning a Boolean, of course. It's actually going to be returning a result wrapper. So what we need to do is we need to say if result1 is result wrapper dot success, then we want to just make sure that it's returning the right value. So in this particular case, oh, I didn't finish that properly. We care not only that we're returning something of type result wrapper dot success, but we also want to be verifying the state. So we will actually make an assertion for that. Assert equals, and we'll say result1 dot value, and then we'll supply as the second parameter valid answer 1, like so. And then else, if we return something which is result wrapper dot success, or error rather, then we're going to say, then we're going to say assert true, false, just to make our test fail. Okay, so that's all we need to do there, and then we can delete that, and we'll just copy paste this for the various expressions. So this will be result 2. This will be result 3. And we need to, of course, fix our expressions here. Valid answer 2. 3. And 3. And we'll just fix this. And there we have it. So we'll just go ahead and run this test and see how it fails. Alright, that's exactly what we want to see, so now we can jump into the implementation. So again, we're not actually going to write this out. This thing took me a little while to actually put together, and the code is even uglier than in the validator. But we will basically just copy and paste it in, and then I'll talk about regex or regex in particular. Alright, so I've copied and pasted in the code for our evaluator, but this thing actually has 2 data classes which we need to add in, so we'll create those now. So I'm just going to make a new package in the data package, and that's going to be called data model. And these things are going to be very simple. So the first one is going to be called operator. And what it's going to look like, we're going to type data class operator, val operator value. And so operator is, of course, referring to either multiply, divide, plus, or subtract signs. It'll be a string. And then why are we creating this thing? So we actually want each operator to be designated as something that should either be evaluated first or isn't necessarily something that needs to be evaluated right away. This is based on bedmass. So in other words, for subtract and add, those things are going to be evaluate first, false. So what we'll do is we'll say val evaluate first, which is a Boolean, will equal check priority operator value. And so what's going to happen here is we're actually going to create a function in this data class called check priority. And what we'll do here is we'll say return when operator value is, so when it's multiply, we want to return true. When it's divide, we want to return true. When it's subtract, we want to return false. And when it's add, we also want to return false. And just for the heck of it, we're going to say else throw illegal argument exception. And we will say illegal operator. So this is kind of like an edge case here, certainly, but on the off chance that we end up with we end up trying to create an operator out of something which isn't these 4 cases, then clearly something has gone quite wrong, either with the input which the user has given us or with the actual code. So that's all we need to do for this class here, and then we'll also create a really simple data model for operands. So I'm going to right click, go to new class operand. Again, it'll be a data class, and it's just going to have a value of type string, and that's all we need to add in. So now that I jump back to the evaluator class, everything should be working perfectly. Okay, so what we'll do now is we'll kind of go through this code a little bit. I won't spend a ton of time here, and we'll talk about how I actually put together this evaluator. Before we get to that, though, there's a point on coroutines which I want to mention. So when you are performing either a network call or a call to a database, or in this case we're just basically doing some number crunching, using coroutines with suspend functions, the way that you can jump to a background thread is by using this with context coroutine builder, and then you supply dispatchers.io. Now, one thing I really recommend here, don't use with context until you really need to. In other words, don't call it earlier in the chain of suspending functions. Only call it, say, in the specific backend Otherwise, you can get some funny errors based on being on the wrong thread when you call back to the logic class, which should be on the main thread. So anyways, it's just a good application of separation of concerns in general. But yeah, this is how you jump to a different thread, in this case a background thread, using coroutines. Anyways, moving on, how this function works, or this entire class works, is that the first thing we do is from our expression, we get a list of the operators and a list of the operands. So get operators, this particular function uses regex, or regular expressions. That's not supposed to say data model there. How it works is we can call this expression, so this is on a string, split function, and then we need to kind of hard code in our regex pattern. So basically how this works is this combination of jumbled symbols basically says what we want to do is we want to select for things that are either numbers or decimal numbers, and we want to split the string based on that. Notice I also call this toRegex function here. And then what we'll do is we will filter out empty spaces, and then we'll create a list of that, and then that will be the output that we actually return from this function. Also, I'm using a map_to function to map from just a list of strings to a list of operators. Get operands is much simpler. We use the same code or similar code as we did in the validator. So we're just splitting by the plus, minus, divide, and multiply. So just to be clear, in this case, since we know exactly which characters to split by, we didn't have to use regex. In this particular case, it just helps a lot to be able to use something more general, but admittedly, this stuff is pretty ugly to write. Anyways, that's how we decompose the expression into operators and operands. And then, of course, we need to loop through them and perform the various operations, but we also need to be aware that we're following the rules of BEDMAS. How this thing ultimately functions is it loops through our list of operands and we keep evaluating them. So let's say we have 2 plus 2 plus 2 passed in. On the next loop, it will evaluate 4 plus 2. On the next loop, it'll evaluate 6 plus 2. And then on the final iteration, it will spit out 8. And then at the end, as you can see here, we return operands, the final, or the only thing present in that particular array, which will be the evaluated value. So the code here is a little tedious and complicated to write, but basically what we're doing is we're grabbing, say, the first operand, second operand, first operator, second operator, and we're really just going to check and see, okay, is this something that should immediately be evaluated? If that's not the case, then we will actually check the third operand and the second operator just to be sure, okay, is this something that needs to be evaluated first? So the end result of this is if we have a situation where we have like 2 plus 2 times 2, we will actually evaluate the 2 times 2 first according to the rules of BEDMAS. So that's it for this lesson. We're almost done here. We just need to write our build logic to wire everything together.